Hey guys, so the last section of chapter 8 is finding the rational roots. So this is going to be one step further than what we just did in 8.5. Right? You have to use the rational root theorem. Okay, so in 8.5 what I did is I gave you a polynomial equation, just like this, looked exactly like this, but I had a little colon at the end, and I gave you one of the possible answers. Alright, so then with one of the answers, you were able to find the rest of them by using synthetic division. Okay? Well, now I'm not going to give you all one of the answers. Instead, I just give you the equation, and you got to solve it. So what this rational root theorem does is it's going to give us, basically, you could just pick and choose random numbers to do synthetic division with and hope that one of them works out with a remainder of 0. Right? But that's a whole lot of numbers. It could be any possible rational number. Right? That's like an infinite amount. Okay, so what this rational root theorem does is a smart person, at some point in history, came up with this theorem that breaks this down and just, I guess, constricts that that big possible amount of rational roots. Okay, so the way you do this, right, this notation right here is just my way of saying that you have a polynomial equation, right, because we don't know what the biggest exponent is, so that's why it's n minus 1. The dot 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 means some other monomials, and you know there's going to be an x term and then a constant term. Okay, the important ones are the a and the d. Right, so the d gives us our h, right, where h is a positive or negative factor of d, and the k, okay, is a positive or negative factor of the a. Okay, so that's going to be important to remember. This and this. Right, I think it's easier to see in the, actually in action, so let's go right to the example. So for this one, remember h is a positive negative factor of our d. So that's plus or minus 1, 3, 9, and 27. Okay, and k is a positive or negative factor of a, so plus or minus 1 and 2. Well, we don't want h and k, we want h over k. So out of all those h's and all those k's, we combine those into as many possible fractions of h over k as we can. So that's plus or minus all those things over 1, which are just those numbers, and plus or minus all those things over 2, which look like this. So it still looks complicated, however, it's better than what we had previously. Okay, so although there's still 16 possibilities here, right, because there's 8 of them and then the negative of all of them, 8 or 16 possibilities is still better than, you know, the infinite amount we were working with before. So with this, we can guess and check with synthetic division until we figure out one of these that does work with our equation to get a remainder of 0. Okay, so you got to be smart about the guessing and checking. All right, we'll set up our synthetic division right here. Okay, you want to be smart about it. Obviously, don't go straight to the fractions. Those are going to be harder to deal with. And one thing that I always look at is the fact that we've got alternating signs in the 2, -8, 15, -27. That usually means you're going to pick a positive number. If they're all positive or negative, you probably need a negative number because you're going to need sign changes. Okay, so that's one helpful hint. I usually start with just something kind of easy. Okay, so I'm going to start with 1. Okay, so it's right now the 2, multiply 1 times 2 is 2, add down, keep working, just like this. It's not going to work because we get a remainder of -18. So that one's no good. It's definitely not 1. So I'd probably try the next one, 3. Bring down the 2, 6, -2, -6, 9, 27, 0. Great, this one does work. Okay, so because that works, remember this is exactly like these problems that we worked with in the last section. Okay, so the synthetic division, what it means is we could factor this original polynomial equation to x minus 3 times whatever we have here, 2x squared minus 2x plus 9. That all equals 0. So that tells us that x could be 3, or 2x squared minus 2x plus 9 equals 0. That we can't factor, so we got to use the quadratic formula. And we get x equals 2 plus or minus the square root of 4 minus 4 times a times c all over 2a. Okay, so x equals, when you simplify that and work it out, you're going to get 1 plus or minus I root 17 over 2. Okay, so those are your 3 answers to that equation. Okay, number 2, This one's nice because we have way less possibilities for h and k. Okay, so plus or minus 1 and 2 for h because it comes from the d, and k is plus or minus 1 and 2 as well, comes from the a. Okay, so the possibilities for h over k are just plus or minus 1, 2, and 1/2. Okay, so you have a 1 in 6 chance of getting it right, so just kind of pick one and go with it. We've got 2, -5, 6, -2. You see the alternating sign, so it's probably going to be a positive number. All right, I'll probably start with 1. Okay, 2, -3, -3, 3, 3. Doesn't work. Remainder 1. Okay, so we gotta try another one. I would usually try 2 next, but since I've done this problem before, I know it's gonna be 1/2. So it works like this. Try 1/2, you get 1, -4, -2, 4, 2, 0. Great, that's exciting. Okay, so we know 1/2 works. We have x minus 1/2, right? We're factoring this big polynomial equation, and we're left with 2x squared minus 4x plus 4, all equals 0. So now we can solve this equation. Okay, from the left factor, we know x could equal 1/2. And from the right, we could set that equal to 0. Let's take a 2 out, so x squared minus 2x plus 2 equals 0. All right, I think completing the square is actually probably the best way to do this one. So x squared minus 2x plus 1 equals -2 plus 1. So we have x minus 1 squared equals -1. Square root both sides. Those cancel out. X minus 1 equals plus or minus I. Add the 1 over. And those are your 3 possible answers. Okay, let's do a couple more examples. So, number 3, we've got a whole bunch of possibilities. Oops, sorry. A whole bunch of possibilities, okay? So h could be plus or minus. Oh, that's a 1/2. That doesn't make any sense. Plus or minus 1, 2, 3, 5, 6, 10, 15, 30. Lots of possibilities. K, 1, oh, plus or minus 1, 2, 3, 6. So h over k is going to have a whole bunch of possibilities. Okay? H over k could be plus or minus 1, 2, 3, 5, 6, 10, 15, 30. Also, all those things over 2. So 1/2, 3 halves, 5 halves, 6 halves we don't need because it's already there at 3. 10 halves we don't need, 15 halves we do, and 30 halves we don't need. Also, all those things over 3. 1/3, 2/3, 3/3 you don't need, 5/3, 6/3 you don't need, 10/3, 15/3 you don't need, 10/3 you don't need, and also all those over 6. 1/6, 2/6 you don't need, 3/6 you don't need, 5/6, 10/6 you don't need, 15/6 you don't need, 36 you don't need. Okay, so all of those possibilities, whole lot of possibilities. Okay, so once you get to this point, you have to work this out. I'm just going to show you how to find all the roots, okay, for this one, and you can continue to work out from there how to work through it. Okay, so you just have to guess and check, and then work from there. All right, so number 4. Okay, we've got similar setup. This one's once again easier because you have much less to work with. Okay, so the possibilities for h are plus or minus 1, 2, 3, and 6. And for k, it's just plus or minus 1. Okay, so h over k is right here. Okay, so there's only 8 possibilities, so we could go right into figuring out what that's going to be. Okay, 1, -8, 9, and 6. Okay, and we're going to try -2, okay? Because I see that this 9 and 6 at the end don't alternate, that's why I'm going to go with a negative number. So we got 1, -2, -10, -20, -11, and that's not going to work. Okay, maybe we'll try another one. Let's just try 2. 1, oh, sorry, I don't need that. I want the 1 down here. 1, 2, -6, -6, 3. Oh, sorry, that's not supposed to be -6. I knew I made a mistake somewhere. It should be -12 up here. So -3, -6, 0. Okay, I got my root there, so we have x minus 2 times x squared minus 6x minus 3, all equals 0, so x equals 2, or, let's complete the square again, x squared minus 6x plus 9 equals 3 plus 9, so x minus 3 squared equals 12, square root both sides, and x equals 3 plus or minus 2 root 3. Okay, now the last problem is a challenge problem. Okay, I'm not going to go through the whole thing because I'll run out of time, but I want to get you started on it. Okay, so for something like this, we have our h and k aren't too tough. Okay, so h is just plus or minus 1, k is plus or minus 1, 2, and 4. Okay, so h over k is plus or minus 1, 1/2, and 1/4. Okay, so not a whole lot of possibilities here, but the thing is, when you work this out, you're going to actually have to do the synthetic division twice. Okay, because we have 4, remember, there's no cube, so it's a 0. Then 3, no x term, 0, and negative 1. Okay, so let's work this out. Let's just try negative 1. Okay, try negative 1, so bring down the 4, negative 4, negative 4, positive 4. So 7, it's going to be too big, it's not going to work for us. Right, so let's try something different. Let's try to not change the signs at all. Let's go with 1/2. Okay, let's try 1/2 here. So we have 4, 2, 2, 1, 4, 2, 2, 1, 0. Great. All right, that one does work. So we have x minus 1/2 times 4x cubed plus 2x squared plus 4x plus 2. Okay, so the thing about this is, once again, we don't know how to factor that, so we have to do the whole process over again and keep going. So that'll get you started, and you could do it, continue on from here, get a new h and k, and figure it out. So that's it for Chapter 8. I'll see you guys in class.